Welcome. We are having an extra class today. It's just a tutorial. But I would like to welcome you to the UBC Ecosystem Modeling course. And I would also like to acknowledge that I am speaking to you from the traditional, ancestral and unceded territories of the Musqueam, Tsleil-Waututh and Squamish people. And the purpose for today is because yesterday lecture was kind of long, the one about Ecosim and Timeseries fitting, and we didn't have time to go through the tutorial. So instead we decided that today I would just walk you through the Ecosim tutorial, which you can find at the course website. There's a link on Facebook, for instance, to where that is. And yeah, that's basically it. I'm going to go through all the different steps here during the next half hour or how long it might take. What we're going to do now is to try some more fits. And in doing so, we're going to be looking at a criteria called the AKAI information criteria. It's a measure for bang for the buck. It's estimates. Well, when you're fitting a model, the more variables that you are estimating, number of parameters in your fit, the bigger that number is, the better fit you're going to get to your model. The sum squared residuals is going to go down as you increase the number of parameters that you estimate. But you very easily get into overfitting. And when you get into overfitting, you're fitting to noise. It's not signal. And another thing we know is that the more parameters you estimated, the more noise you fit to, the worse the model is going to do when it comes to estimating or making predictions. So more parameters, better fit, poor predictive capabilities. That's a general rule that holds pretty well. So we try again. Open up our Anchovy tutorial. Then go to Ecosim, load our time series. Go straight to run Ecosim. I want to be sure that nothing has happened to the model. That looks fine. We have the usual, I forgot to save it. I will have to do this again because I like to see what I'm working with. I even save it this time. Okay, and then we go fit to time series. We go search group time series, and now it's going to be searching for, I'm just going to make it a little bit clearer here by taking 10 instead, that these are 3 different colors. So it's going to search for seals, cod and whiting and estimate a parameter for each. So we do a search. A little bit more space. Here you can see on this table here, we're getting an overview of each run, and we may have to do many runs. And even if you use the automated routine that we talked about yesterday and that Jacob Bentley talked about almost 2 weeks ago in his class, even if you use that automated routine from SAMS that does all of these different steps, you don't go there directly. you start off by exploring your model and figuring out if there are any issues with that. Well, we actually see we didn't get that great fit here, from 40 to 37 only. Now that's weird. So that was not very efficient. Let's go sensitivity of sum squares and try to do the same as we did before. This surprises me. And we did 2. Okay. Search again. We were down to 13 before. We still start at 40.47. Whoa, it runs straight down again. So group 7 is really important for this. That's what this indicates. So this is a case where just searching for groups for time series is not giving a very strong reaction. Now if we have 2 runs here, and if you look at it now, it says the number of parameters, when we estimated 3 parameters, there were 19 ARC data points assumed in this. I'll come back to that. We have a sum square of 37, and AKAI information criteria AIC is 20. When we only estimated 2, it was -2. Let's just try go back in here again and do 5. Do a quick one. Just one more number just to make it clear. 5. Okay. Search. We need a little bit more to see the pattern in this. So we're back to 13.5. We ended at 13.290, down to 9 now. So obviously we're getting a better fit, but we're estimating 5 parameters instead of 2 parameters as before. Probably, oh, it's still going down, 8.15. So if we look at these now, the 3 runs we have, and we look at the AKAI information criteria AIC, there are different kinds of ICs. AKAI information criteria, we're looking for the one that has the lowest number, which is the -2. So the one where we estimated 5 parameters, that one has -1.4, so it's higher. So the model is telling us that going from 2 to 5 parameters didn't give enough reduction in sum squares to pay for these 3 extra parameters. So it's indicating we may be heading into overfitting with this. And we're just estimating 2, 3, 5 parameters. You can imagine what would happen if we go out and we did it by peer-to-peer interaction, or if we know now that if we are adding more than 5 parameters, we are going to get we're not going to get the better. It's possible we could find some around with 3 or 4 that are better, but if we go 6 or 7 or 8, we're going to get lower sum of squares, lower residual sum of squares, but we're not going to get a lower AIC. There is, however, one factor with the AIC. That is this assumption. There's an assumption, or it doesn't sound like an assumption. It sounds like a straight number. Number of AIC data points, 19. If we go back to the time series and we count, so for the data series that we have, that is, for zeros we have 6 data points. For Coll we have 5, I think. That's 11. And for whiting we have 5. That's 16. And then we have shrimp with 3. That's 19. That's our number of data points. So that's how it comes in here. number of reference values in the time series. Now the underlying assumption is that these values are independent. And independence in data is something that that assumption, I don't know if we ever live up to that when we're dealing with ecosystems in biology and sampling and surveys and so on. If the data comes from an assessment model, well then the biomass the first year, the biomass the second year is the biomass the first year plus the growth in that population less the catch in that population. That's not independent. If it comes from a survey, well, your methodology matters too, and the way the setups are done. So your estimate 1 year is not going to be independent of how it was the same year. It's going to be the same kind of bias and other things in it. So what it points to is we don't really know how many independent data points we have. But you can still use AIC to get it published and so on. That's expected that you look at this, and you should. You should because it points you to be careful with how many parameters you estimate. But one thing I suggest and I like to do is to say I don't know exactly how many. I don't know how many independent data points we have. So how dependent are the findings of how many there are? Well, what if we say we don't have, if we don't have 19, but we only have half as many, 10? What would that do? Well, now we got calculating it with 10 data points. We're finding, well, the 2 is still the lowest value. And if it becomes even lower than that, if there are only 5 data, this is weird. Oh, this is really weird. The AIC becomes lowest with 5. That makes no sense. No, that's because we've the 5 is simply not enough to estimate 5 parameters. The equation breaks down. In this case here, it's consistent. But if we had 100, then you see, then we can estimate more parameters. Now it says that the 5 is okay. So this number matters, and I like to check when I work with this how robust is the finding about which is the best model to the assumption of independent data points. They do correlate, and it's often overlooked. People use AIC, and everyone uses AIC. This is not an Ecopath thing at all. This is what you do when you evaluate alternative models. AICE or Bayesian information criteria, there are lots of different kinds. AIC is one of the first, and it's a respected measure of it. So this is what we do for the fitting. We basically the steps we'll be going through here. And I've only talked about one aspect of this, that's fit vulnerability search up here. There's another thing we can do, which is called an anomaly search. So I'm going to click that one, and right now unclick the other one. And this thing is looking for a primary production anomaly. So we're going to see the impact of environmental change, how that may have impacted the system in quite a specific way. When we read in the time series, there was a dummy in the time series, which doesn't even show up here because it's being read in as a forcing function. But in here, we have one called dummy. Now, it's just a flat line. And I go over to Ecosim input forcing function and then apply forcing to producer. So this button here, option here. I can go in here and I can click this cell for phytoplankton. And then I have on this pop-up screen bottom temperature or dummy. I take the dummy and I click it and it goes over to the right. Now I have applied it to primary production. See here, forcing function 2 has now been applied to phytoplankton. So we go back to fit to time series. And now it shows up here. And it shows up here with all of these lines, indication here. That means with the setup here, if I run it now, it's going to estimate a primary production for every year. And do that in order to see if that can improve the fit with time series. Now, given that we have 19 points and that we had before that the best parameters were down to 2 or 3 or 4 or something like that, the best number of estimated parameters were down to 2 or 3 or something like that. That kind of numbers, very few. Going out and estimating how many is it, 50 or so parameters, that's going to lead to too many. So instead we can use something called spline points. So here I have 3 spline points. There's one here, there's one there, there's one there. I can also try to make it clear by going 5. If I use back to 3. If I use 3 now and I run it, what the program is going to do is it's going to draw a curve here, but it's quite limited what it can do because it's going to put 1 point at start of the simulation. It's going to put 1 point here, and it's going to put 1 point over there. Let me just run it and it becomes much clearer what it does. And it draws a curve between those 3 points, but it can only do this by regulating those 3 points up and down. So we're starting off now and we're estimating only those 3 parameters. And we're still going back to resetting it, but you can see now it has estimated 1 parameter here, 1 parameter there, and 1 parameter up there. So maybe that's a bit rough, just having a scale like this, but what this recognizes is if you add more, if you have more data series and you can estimate more parameters, is that you can get to something that has decadal changes represented in your model by this, or something that that changes, that has more productive periods and less productive periods. You don't need to estimate for every year. If you estimate for every year, that is, if you set the spline points to 0, you are likely to be fitting to noise. The program will go out and it will see, oh, there was a value for shrimp in a certain year, and I'm going to go out and the year before, I'm going to increase the primary production a lot so I get a lot of shrimp next year, or that kind of things is what's going to happen. It's trying to fit to that, basically, it's noise that comes out of it. So one really has to evaluate what happens here. So now we've estimated this. What we can do now is that we can go back and we can see what has happened. I can go back to vulnerabilities and see what's there, and it's not going to be a surprise. It's all 2s because it resets it. That's what we're telling it to do. But it's estimating a forcing function. You saw it before, and we can try to run Ecosim. And when we do that, we see what it's done. See, it has changed the system into a very productive system. And it has done so in order to chase some points. That's basically what it boils down to. We had caught decline before. It's going to be helped a little bit by having a more productive system so it doesn't crash as much. And then we have these increases here in seals. That's what it's hunting for in it. See, 0.62 for seals caught are still very high. But it's trying to use the environmental productivity to make a more productive system. So, what's next? Back to time series fitting, fit to time series. We tried this now. We could try to see what happens if we do vulnerability search and anomaly search. So we can do both of them, that's fine. We just have to remember how many parameters we're estimating. We saw here, by the way, if we go back to 19, the last run we did, some squares were 33 and the AKAI was 18, so actually better than what we searched for the tree groups with time series there. There the AKAI was 20. Not a big difference though. But let's try now, and we're going to go back to vulnerability search because we need to decide what we want to fit to. Let's just see why shrimps is so important. What information do we have about shrimps? We have catch is up there. Oh, I can have all the plots. We don't want that. That's what comes when you don't save. If you save, this is going to be saved with it for next time. Obviously, I haven't been saving. Oh, now something weird happened. Hi, how can I help? When does summer begin? What gate is Delta Flight 35 arriving? I mean, this is fantastic. Okay, here we can see what it's been, why, obviously in the start situation, changing the vulnerability for shrimp had a big impact. But we're changing these 3 catch values. And the problem we have is that in Anchovy Bay, there was a sim frizzy that took off and led to those catches. But we don't have it represented. We don't have an effort for that fleets. We're missing that kind of information. We're missing that driver. So we're trying to instead seeing if we can get closer to that fit by increasing the phytoplankton production. It's not a very plausible hypothesis, but the program is doing exactly what it's being told to do. So let's go back to fit time series, and we can do actually just search group of time series. It makes no sense to be searching for shrimp when we don't know anything about what happened to shrimp. And we don't have a driver for it. We only have a catch. So now we're going to search, and I'm going to go back to anomaly search, and hopefully it's going to be resetting the graph. No, it doesn't. See, it starts at 33, so it's actually going to start from that, but it's going to be moving from this starting point, and that's perfectly fine. It's probably going to realize that this is not going to help too much. No, it's going to go even further out on that limb there, which is not very plausible at all. And basically, the program just does what it's being told to do. You do have to evaluate that, and you can see here we have a fairly small reduction in the AIC, and the AIC is the highest we have. So estimating 6 parameters as we're doing here certainly isn't going to, didn't work at all. It used to, no, it's not doing that anymore. So let's go back to forcing function. Just curious what would happen if I take this one and I reset it. Wrong place. You have to play with it. That's what this amounts to. Even if you have a big setup and you're going to do automated searches where it goes steps through all the different pathways, you have to go out and check what's going on. What kind of data do you have? Do you have groups like shrimp, where you don't have any effort, but you see the impact of the increase in effort? How many do you miss drivers? And if you do, one thing you can do is, just like Jacob Bentley was talking about, that talk to fishermen, find out what has happened over this period. What has happened with the effort? How many boats are there now relative to what there were before, and that kind. So it's taking us back to, at least it's pretty stable in taking us back to something that's very similar to what we did before. That's basically it. I think we've been through a good part of what goes into it. There are some various things you can do, capping fishing mortality up here to make sure that nothing is going to be extinct because of it. But no, I want to, actually, there's one more thing I think we should look at. That is, let's get rid of this forcing function again, just to speed things up. Forcing function, reset. In here, and stop the anomaly search, and let's just try to add whales into the picture. So now we're searching for a group for which we don't have any time series. So with the other three groups here, we ended up at 37 in some squares. Now we are at 36.9. It's a very small difference. I'm just curious to see what's going to happen to whales if when we do this. Yeah. So so this here has some squares of 23. So it's actually higher. Its AIC is quite a bit higher than when we didn't search for that. Let's just have a look at group plots. I can go straight to group plots. I don't have to go on one. And what we're seeing is that quite a big increase in whales. And we can look at the vulnerabilities and see it has increased the vulnerability for whales up to 72. So it's saying whales are very far from the carrying capacity. The program doesn't know anything about this. So the most likely thing that has happened is that whales are being set to that high vulnerabilities because for some reason there is some reason behind this that makes them increase. Well, we have actually, sorry, there is a reason. The reason is biomass accumulation. So by increasing that, we're getting a bigger biomass accumulation on whales. And what it's doing it not because of whales, but because of the impact they have on one of their prey. So it's an indirect effort that makes them jazz up that vulnerability for it. And that's one of the cases, again, where one has to go in and think about, well, is this reasonable? What do we know about the system? You have to have that kind into. So is it reasonable that whales have decreased that much? Do we have any indication about that? Do we have counts and so on? Maybe try to get the data. Otherwise, you may end up, when you are estimating parameters for groups where you don't have time series. No, when you are estimating groups, when you are estimating vulnerabilities for groups where you do not have time series, there are no constraints on what happens to that group. You're not giving it constraints. There may be because of the impact they are having on something, but it's much better if you think about it, look at it as we're doing here, and trying to figure out why is it doing this. And it can be because of the impact it has on prey. It can also be because it has an impact on a predator that has and is the impact on its prey. It's a question of where the time series are. That is reacting to. So be careful if you're estimating parameters for groups where you don't have time series. Think about, check what happens, look at diagnostics, and really consider, is that smart, or what do we know about it? Well, in this case here, we have a good reason to think actually that whales would have a vulnerability that's bigger than 2 because they were depleted, they were recovering. But this is how we look for it.
Yeah, I just want to say thank you, and it's totally clear.
Oh, good. All right. Thank you all.